Okay, this is Mrs. Martin, and this is directions on how to make a graph specifically for the sponge animal lab, but it also works for other labs as well. Whenever you're making a graph, the first thing you want to do is you probably want to make sure that the circles for the hole punches are at the top of the page. Usually you want those up here so that they're not in the way of your lab. You want to make sure that your graph is as big as the piece of paper that you're using. You don't want little tiny graphs in the corner. The first step of making a graph after you've oriented your page is to make the lines that are the y-axis and the x-axis. Usually you make these about 3 to 4 squares in from the edge. You don't want them to be very far from the edge. You want them to be very, very close. So that's the first step. Make the x-axis and the y-axis. The second step is to put numbers on the x-axis and the y-axis. In this particular lab, you want to put time on the bottom. In fact, we always put time on the bottom in this science class. So if time is present, it will be on the x-axis, which is on the bottom. Because this lab you have 900 seconds or so to actually do the lab. You have 15 minutes to get the actual measuring of the time done. So that means that you're going to have to get the data on this graph. Well, there's not 900 boxes here, so you're going to have to go up by a particular amount of numbers. In this case, I recommend going up by 30s. If for some reason your biggest number is significantly bigger than 900 seconds, you might have to go up by 60s, but that would just be by one data point, so on second thought, just go up to 900. So if you're going up by 30s, it'd be 0, 30, 60, then here it'd be 90. I don't think I can make a 90. Nope, I can't. So let's see, do I have an eraser? Nope. Okay. Oh, I know. There. So 30, 60, 90. Numbers need to go on the lines. Now this is strange because if you put the numbers in the spaces, you are messing up. The numbers have to be on the lines of the thing. This is a little bit different than your habit, so you need to make sure that you do that. All right. So that's the next page. When you are going up on the y-axis, that needs to be the temperature. In this case, the biggest temperature you're going to end up with is about 100 degrees. You only have about 20 squares to represent those 100 degrees. Now, under normal circumstances, you would take 100 and divide by 20, and that would get you about 5, so you'd have to go up by 5s. However, I need a little bit more detail, so I want you to put in this little squiggle here, and what that means is that you're skipping a space, and then I want you to go up by 2s. And with that, that'll take you to about 75 degrees, and that will get most of your fake data on the graph. All graphs need a title. This one will be time versus temperature, and the title goes right here. You could also write Sponge Animal Lab. Once you have the time across the bottom and the temperature in Celsius going up, then it's the time to actually do the graphing. And how that works is you need to find the time on the x-axis and the corresponding temperature on the y-axis. So let's look at this first one right here. There are two numbers here. These two numbers go together. It's 75 and 47 together make one dot. So The 75 is the time, so let's find that here. Here's 30, here's 60, here's 90. 75 is in between, but then I have to go up to 47. So here's up at 29, here's up at 33, here's 36, so we went up by 1, 37, here's 40, 45, 46, 47. So here is where these two numbers tell me to put the dot. It's 47 and 75. 75 over, 47 up. This next one here, time is 600, so that brings us over to here, this spot here, and then up to 33. So up, 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 and here's the 33. See, if I go over, see, there's 33. So here is where the next dot goes. The last one's 245 and 37. 245, well, here's 240, and this is a lot bigger. So this 45, I'm going to have to round because I'm going up by 30 seconds of square, and 5 just really isn't very much. So I'm going to have this just on the 240 mark. So I'm going to have it on 240, and I'm going to go up to 37, 35, 36, 37. Let's see if I'm right. I'm going to take this one here. Oops, switch it to the arrow. This one here, and I can actually grab it and drag it over so that it matches. And you can see that I have them all in the right spots. When you're done with the graph, it'll look something like this, or like that, or like that. So you need to know what this actually means. The thing with sponge animals is that they're not exact. They don't open at precisely the right moment. So there's like a range. So instead of a nice straight line, you get this kind of oblong shape. Looks like they're all like in this great big circle shape, this oval. Now the oval will still tell you the relationship. So if you look at it, it will say, here we have a high temperature, because this is a temperature of 47, and a low time, 150. So high temperature, low time. And look down here, do I have any high temperature, high time? No, it's an empty spot on the graph. Do I have any low temperature, low time? No. I do have high temperature, low time, and I have low temperature, high time. So this graph would tell me that as temperature goes up, time goes down. And that's a relationship that I would be able to understand based on this graph, or a graph like this. This graph, I have low temperature, high time, so I have that over here, and I have higher times with higher temperatures. I don't have anything here or here. So this would tell me that the warmer the water, the longer it would take. So as temperature goes up, time increases. This last graph talks about the fact that this last graph talks about there's no data for low temperature or low temperature, low time, and there's no high temperature, high time. In fact, all of the data is right here in this column. So what that would tell me is that as temperature goes, there's no relationship between time and temperature. They're going to open at about this time no matter what the temperature. High temperature they open at this time, and low temperature they open at this time. So that is how to set up the graph and how to interpret the different types of graphs that you might get from this lab. Hopefully that will be helpful.